Today we're going to start a unit on statistics. I'm not going to be in today, but you're going to use this video and our notes and take notes like we normally do. I'm sure you're going to remember some of this from geometry and middle school math, so this shouldn't be very difficult. We're going to start with the fundamental counting principle, which is a method of using multiplication to count. So it's kind of a quick way to count up a bunch of things using multiplication. I put the definition here. If event M can occur in M ways, blah, blah, blah. Sometimes these definitions aren't as clear as we would hope they could be. So let's just go to the example and see how this makes sense. So if you have 4 pairs of pants and 8 shirts, then we can create how many outfits? So if I have pants and shirts, and I have 4 choices of pants to wear and 8 choices of shirts to wear, if I multiply those together, I will get 32. So we can create 32 different outfits from those 4 pairs of pants and 8 shirts. That's a simple problem. Let's try a more difficult one. An old website requires a 4-character password consisting of 3 numbers and 1 letter. A new website requires a 6-character password consisting of 3 numbers and 3 letters. How many more passwords can be made for the new website? So let's start with the old website. 4 digits altogether, 3 of them numbers, 1 of them a letter. How many numbers can we use? We can use numbers from 0 to 9, and there are 10 numbers from 0 to 9. And we can use 1 letter, and there are 26 letters in the alphabet. So if we multiply that together, we will get 26,000 different passwords. Quite a bit. But the new website says we need to have 6-character passwords. 3 of them have to be numbers. So we said we had 10 numbers from 0 to 9. And then 3 of them have to be letters, and we have 26 letters in the alphabet. And that gives us a total of 17,576,000 passwords. 17 million, that's a bit. Now, how many more does that create? Well, if we subtract, we will get 17,550,000 more passwords. Let's try one more. Oops. So, at the ice cream store, you can choose from 8 flavors of ice cream, 5 fruit toppings, and 3 syrup toppings. How many different sundaes can you make using 1 flavor ice cream, 1 fruit topping, and 1 syrup topping? So I have 3 choices to make. 8 flavors of ice cream, 5 fruit toppings, and 3 syrup toppings, which multiplies together to 120 different sundaes that we can make. So the next thing we look at is permutation. A permutation is an arrangement of items in a particular order. So you can think of me putting some books on my shelf and how many different orders I can put those books on the shelf. We're going to be using some notation called factorial notation. It's a shortcut to write some multiplications. So here's how it works. 3 factorial, which is red, 3 factorial equals 3 times 2 times 1. The exclamation point is read as the word factorial. So 5 factorial will be 5 times 4 times 3 times 2 times 1. 4 factorial will be 4 times 3 times 2 times 1. And of course, you can multiply these together. I'll get 24. So if I go back to my example about how many ways I can place my books on a shelf, let's say I have 8 books to place on the shelf. So let's do this the long way first, and then I'll show you the shortcut. So there's my 8 places to place my 8 books. Now, counting principle says if we figure out how many plays we can get each book, we can just multiply this together. So I got 8 books on the table I want to put on the shelf, so I can pick any of the 8 to put in that first place on the shelf. Now there's 7 books left to put on the shelf, so there's 7 to choose from for the next position, 6 to choose for the next position, down the line. So we would have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 ways to put those books on a shelf. And we just said that that is the definition of 8 factorial. Now your calculator has a button that will tell you what the factorial is. So if you go to the math key on your calculator, and you need to go to the right where it says prob for probability, and you should see a screen that pops up where you see that exclamation point. So if you do 8 followed by that exclamation point, you should get 40,320. Now we could just do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That'd be time consuming. So how many ways can we line 3 people up at the water fountain? Again, 3 places, 3 ways to choose that first person, 2 ways to choose the second person, 1 way to choose the third person, which is the same as 3 factorial, or 6 different ways. We have a formula to help us find permutations. It works well when we have to multiply or find the number of ways when we have more things than there are spaces. So the notation is NPR equals n factorial over n minus r factorial. So 10p4 would be 10 factorial over 10 minus 4, or 6 factorial. And we can put that into our calculator and get 5,040 for that permutation. So 8p5 would be 8 factorial over 3 factorial. And 6p2 would be 6 factorial over 4 factorial. Now if you put 8 factorial over 3 factorial in your calculator, you get 6720. If you put 6 factorial over 4 factorial, you get 360. I'm sorry, you get 30. Can't read my own writing. Now, we can use this NPR formula for problems like the next one. 9 students are in a race. First, second, and third places win medals. How many ways can 9 students finish first, second, and third? So if we do this the old way, first, second, and third place, there's 9 people that can win first, 8 that can win second, 7 that can win third, and that will come out to 504 different ways. Now if we want to do it the new way, NPR, it would be 9p3, so we have 9 people racing, and there's 3 medals, which is 9 factorial over 6 factorial. And if we put that in our calculator, we will get 504 again. Now, let's say there are 8 players. We can do the same game. 8 players. We want to choose first, second, and third baseman. So 8 ways to choose the first base, 7 to choose the second, 6 to choose the third, and if we multiply that together, we get 336, which is the same thing as if we did 8p3. That will give us 8 factorial over 5 factorial, and we will get the same answer. The last thing we're going to look at today is a combination. A combination is an arrangement in which the order is not important. Again, we have a formula we can use here. The number of combinations of n items of a set chosen r at a time is NCR, or n factorial over r factorial times n minus r factorial. Now this order not important thing is, if I was going to say put my books on the shelf, it doesn't matter to me what order they're in, then I would use a combination. If I do think the order is important, so if I move the books around, that's a different arrangement, then I would have to use a permutation. So, as you can see, 5c3 is 5 factorial over 3 factorial times 5 minus 3 factorial. And we can again put this in our calculator. If you go back to that math prob screen, there is a NPR and an NCR button, so you can do it quickly there. Or you could actually calculate this out, 5 factorial divided by 3 factorial times 2 factorial, and you should get 10 for an answer. So if I was doing 7C4, that would be 7 factorial over 4 factorial, 3 factorial. And again, we're going to learn how to put this in our calculator. We should get 35. And if I do 8C7, I should get 8. So take a minute and play around with your calculator and make sure that you can enter these in the calculator and get that answer. If not, that's something we're going to have to look at tomorrow, okay? So, example of a word problem here. You have 20 songs in your MP3 player. You have time to listen to 4 of the songs. And how many ways can you select 4 songs if order does not matter? So since the order doesn't matter, you just want to pick 4 songs. We're going to do 20C4. And that would be 20 factorial over 4 factorial, 16 factorial. Or if you figured out how to use that NCR button, you can enter it directly, and you should get 4,845. Last problem, we have a raffle at school carnival awarding prizes of $150, $25, and $10. If 25 raffle tickets are sold, how many different ways can the prizes be distributed? Now, I'd want to ask you here, do you think order is important? If the first ticket drawn is getting $100, then wouldn't you want to be that first person? So order actually is very important on this problem. So instead of using a permutation, we're going to use, or combination, we're going to use a permutation. So 25p, how many prizes? 1, 2, 3, 4 prizes, which would, so that's 25 factorial over 21 factorial, which would be 303,600 ways to award that prize to those 4 people. So you have a worksheet, 11-1 practice. It has 2 sides to it. I want you to try every problem for tomorrow. They're very doable. If there's some that you can't do, then we will go over those tomorrow, but I'm pretty sure you're going to be successful on these. If you have problems, you want to go to the math lab. The math lab is open all day today, so that's something you can do.